Planetary Exploration Rover. Today, we start the chassis build. Coming up next on Mikey's Lab. Welcome back to a different, not the lab. Today I'm at my buddy's house, and we're here because we have a workshop environment that will make this easier to do. I don't have my lab coat on because loose clothes are dangerous around power tools. Turns out I'm not using power tools, but hey, safety first. Today we're starting the chassis build. This will be the first part of probably 3 or 4 different parts. We're going to ignore the battery tray, the electronics tray, the support structure that holds the solar panels in place, and our mast. Those will come in later videos, and if you don't know what I'm talking about, don't worry, neither do I. We've chosen to work with an interesting material today. We've chosen to work with PVC for 2 reasons. 1, it's cheap and I'm poor, and 2, it's really easy to find tools that are able to cut this and work with this. This is a perfect material for what we intend to do and will work beautifully for what we want. So working with PVC, primarily what we're going to need is we're going to need a drill with a drill bit, and we're going to need a hacksaw, and we're going to need PVC glue. Those are really the only tools that you need to work with this. Now I have based my design off of another YouTube video's design. I've modified it for what we want, which is our rule. I will never replicate somebody else's work. I will always modify it and make it my own. His design will function as the base of my rover. My rover will have much more autonomy to it. My rover needs to function like a rover. His functions very much like a radio control car. I will link his video in the description below so you can check out what he built, because he did do really good work. We will be going well beyond that in the later videos that are here. Let's dive down to the bench and let's start building the chassis for this rover.
Okay, so what we have laid out on the table here is everything that we're going to use. Let's take a moment and dig a little deeper into each piece. Here we have the motors that we're going to use with this particular rover. These are 100 RPM 12 volt motors. While they will not be permanently attached to the rover at this stage, they'll be used as part of the mock-up to see what they look like. These 45-degree turns are going to be used in the upper part of the chassis. There's actually going to be 4 of them, but there's only 2 pictured here. These are 2 PVC T's. These will be used in the upper chassis to allow us to connect the levels higher. You'll see them later on in the video. This is blue Loctite. Make sure you get the blue kind. The blue is breakable, so you can't undo the screw. It just takes a lot more effort. Don't use red. That's permanent. Here we have some PVC cement. During this process, we won't actually use this, but once we're 100% certain in the configuration of the rover, we will use this to secure all the parts together. And we have 1024 nuts and bolts. These will be used to join the various pieces of the rover together in areas that it needs to pivot and areas that it doesn't need to pivot. You'll see as we proceed with the build. These are just standard flat pieces of aluminum with holes drilled through the center there. They're going to act as braces for part of the chassis. And a tape measure, obviously, something you want to use on every project. A hacksaw. I recommend spending a little money and getting a decent one. This one's from Canadian Tire. Cost around $17, came with 3 separate blades. Make sure that the blade you're using is for PVC or plastic. A miter box is very, very handy to have on a project like this. It will allow you to get straighter cuts up and down. Not that in the end it matters with the PVC couplers being the way that they are. They're going to cover most of this. But get one that could be secured to your bench. I wouldn't recommend plastic now that I've used it. Try to find a wood one or even a metal one if you can. Now we have 90-degree turns. These are going to be used on the 2 front legs, and they're going to be used to form the square that becomes the middle of the top of this build part of the chassis. And this is just a bag of washers. I bought various sizes, several quantities of them, more than I will need. I just wanted to have them kicking around. They're for the 1024 bolts that we're using. And then I got 10 feet of PVC 1 1/4 inch, I believe this is, pipe. This will be the main structural components.
We have standard 1.5 PVC. This is what we're going to be working with for the majority of our chassis. It is very, very strong. It is very rigid. It'll be the perfect material for what we want to build today. Now, working with this is easy if you have the right tools. I recommend buying a good hacksaw, because if you try to cut this with a wood saw, like I did earlier today, you're gonna have a bad day. Now, one other quick tip. You may be tempted to measure out every cut that you have to make already and then make it in one run. That is generally a mistake that most woodworkers will tell you is a mistake, because you'll forget to take the width of the blade into consideration and you'll forget which side of the line you're supposed to cut on. So mark one, cut that one. Mark the next one, cut that one. That guarantees that you'll get consistent results across every time you try to cut the pipe. Creating a cut list of what you want to cut is a great way to ensure that you get every piece that you need to assemble in the first place. So if I look at my cut list, not upside down, I know that the first cuts that I have to make are 2 18-centimeter pieces, then 2 15 and 4 13. So let's mark that up and cut those now. Now with a permanent marker, you'll notice that the tip is not exactly a fine point. So it's important that when you mark where you're going to cut, you remember which side of the line you marked on. I like to mark away from where I needed to cut. So the black line should remain on the stock that I have not cut yet. So that's 18 millimeters. And now we're just going to take the PVC. We're going to put it into our miter box. Use the built-in clamps to clamp it down a little bit so it doesn't move much. Set it up so the blade will be just on the right side of the line. And again, release it. So now we have an 18-centimeter piece. I'm not going to make you sit there and watch me cut a dozen of these cuts. So we're going to jump right ahead till I'm done cutting this and we start the assembly. I'll tell you one thing for sure. Using the right tool really helps make this easy. Another beautiful thing about working with PVC is once you attach the ends to it, even if you didn't get a perfectly straight cut, because the ends itself and the way they're shaped, no one will ever know. Never buy a plastic miter box. So now that we've got all the pieces cut, let's take a moment to top up our drink, have a vape, and then we'll dig right into the assembly. Okay, so once you're done cutting all those pieces, the next step is to clean up the edges. If you've ever cut PVC before, you can see that the edge just burrs a lot, right? So the first step in cleaning it up is to literally just take your hand and, like I'm doing right now, rub off the extra pieces. And now be careful, because these edges can be very, very sharp. And once you've gotten everything that you can get off with your hands, it's time to take a bit of sandpaper. I like to just and that will smooth that out, and then just on the sides as well. To make it not sharp. And it doesn't have to be perfect, you just don't want it to cut you. So I'm gonna go ahead and do that with the rest of these. I'm gonna jump cut this because I don't wanna make you watch all this. All right, so I originally intended to buy caps to cover the ends at the side there and make it the same size as the joint in the leg that we're gonna bind to. I couldn't find them, however. So I bought a couple of tees. I'm gonna cut them down and make them basically spacers to hold the PVC at the right distance. So again, hacksaw. The inside of these is not quite as important since the tube will be going inside, not actually any wires. All right, so the first thing we did was we inserted one of the 5-centimeter coupler pieces that we created into a 45-degree turn. Allows us to take the expansion piece that we just made, stick it on the end of this, and get a very, very snug fit into there. Holy crap. Oh. That is not coming apart, ever. Okay, so from here, this is gonna be part of the back leg that goes to the back of the Rover and comes down in the long piece. So the next piece we're gonna need is a 10-centimeter piece, which I'm gonna bet is this one, but always measure. So the 10-centimeter piece connects to that 45 like that. Okay, and again, pressure fit as tight as we can get. When we're 100% certain that this Rover is exactly the formation that we want, we'll PVC glue all of this. Next, we take another 45-degree angle piece and we shove it onto the end, making it look very much like that. The next piece is one of the longest pieces that we have, an 18-centimeter piece. Right, we want to find the best end that we have for this because that end's going to remain exposed. So once again, pressure fit it in place, and you should have a leg that looks like this. Okay, so now we're going to build the front of the rocker bogie, which is two 13-centimeter pieces. Again, we're looking for the cleanest edges that we can find to leave on the outside, and a 90-degree turn. So fit those together like so, and like so. And this is the general layout of what this is going to look like when we're all said and done. All right, we're going to have these metal strips here to secure that, about like so. Now I will admit, with this project I got very lucky in one way. Take a look at the motors that I have. Just so happens that they insert into the PVC piping with less than 1 millimeter to spare. So that's how we're mounting those after. So in essence, what you're looking at is So I'll come over here. That is our target. As our base. All right, so let's just quickly build the other one. I'll probably jump cut because it's going to be identical to this, and we'll get this underway. All right, so now we have the two legs laid out and we understand that we have all the pieces together before we start screwing things together. The next is the piece that joins these two together. This will function as the base for the upper layers of our robot when we're ready to start building them. That is simply a series of 4 turns with the remaining pieces of pipe. You want it narrow in the length and wider in the width. So we take the longer one, insert it into the side there like that. Take a shorter one to the other side. Shocker, we put another 90-degree on here. And we put the longer one on again. So we have a U shape at this point. And we're gonna take these 2 last 90s, attach them to this short piece like so. And then attach them to form a complete base. Again, I don't know if we're actually going to need glue for this because these just do not want to come apart when they're together. So we're going to line this up so that it's centered. Go straight through the one side, keeping the drill as straight as possible. Start into the other side. Put it on top of here so that we don't wreck the bench. Okay. So now once again we're going to take this. We're going to use the metal piece as our template. I'm going to remove the metal piece from this equation. We're going to go over here. Keeping the drill as straight as possible. Right through out the other side. You can see the hole there and there, there and there. Okay. Now we need our metal braces. I try to take all the packaging off of them. Sometimes I'm more successful than others. All right, so we're going to take 2 screws. We're going to grab our bag of washers. So what we're going to do, we have one of our metal braces, we have one of our ends. I just totally forgot to put a washer on there. Washer first. Metal brace. Shove it through the hole like so. Grab another screw, another washer. Put this up. Put this in like so. And we go with another washer. There. The other metal brace comes onto the same side, or the other side. Another washer. for both of the nuts. And then this is where we're going to deviate a little bit from the other video. We're going to use a little bit of Loctite, so we only have to use one nut. This is blue Loctite, which means if we ever want to take it apart again, we can. Very important, don't use red. There were side cutters right here. There they are. We're just going to go ahead and snip the tip. Put a little bit of Loctite on both. That was plenty. Now eventually I'm probably going to trim these screws. Truth be told, I had originally purchased these screws to use with it, but they're not long enough and I made a mistake. So we're going to go ahead and do that. And tighten this part down a fair bit. Okay, doesn't have to be super tight because the Loctite's going to take care of a lot of the securing of that. All right, so now on the next part, we need this to pivot, right? So we only want one screw to go through it. So if we find the center point where that makes the most sense, right about there. We drill into it on the one side, and the same thing as before. Go straight through to the other side as straight as we can, and right through. Okay. Same thing as before. Screw, drop the washer on the ground, screw, washer. We line it up with this plate here. Actually, I want to do that the other way, so it's uniform. When you guys are doing this, a slightly bigger drill bit might be beneficial. But I did not think ahead, and this is the biggest I have. Okay, and then once again, another washer on this side. A little dab of Loctite on the threads. I don't know how close you got in there, Josh, but show the Loctite. And then again, the single nut just to capture that. Again, we don't want this super tight because it does need to pivot here. We'll let the Loctite handle the knot backing away, but we'll just go a few turns here so that there's some friction. Okay, so what we have one of the legs done here, where you can see the front is free to pivot. while the back end remains stationary, allowing these two wheels to come up and climb obstacles. It's a beautiful system. They use it on numerous rovers, so we're duplicating it here. So I'm just going to quickly repeat that process again, and we'll jump cut to the next piece. Toasty. Wow. That chuck is as tight as that chuck's gonna get. It's total. Okay. So then, take this guy right here. Alright, so today we completed the initial stages of the build of the chassis for our rover. At this point, it is honestly ready to sand and get ready to paint. There are a couple more modifications that we need to do in order to accommodate the expansions that we intend to use for some of the more advanced features of this rover versus what it was inspired by. Again, link in the description for credit where credit is due. If you haven't already, go ahead and click that subscribe button down below to ensure that you get all the latest updates on science, technology, engineering, DIY, and more that we put together for you every single week. Once again, I hope you learned something today. Thank you for joining me in the lab, and I will catch you next time.